Question 23. A stone is allowed to fall from the top of a tower 300-meter height, and at the same time another stone is projected vertically up from the ground with a velocity 100 meters per second. Find when and where the two stones meet. Maybe here he is not concerned about when, because in options there is no second. So you can find where the two stones will meet. I think he has given x, represented x, meaning maybe he is trying to ask for x. Okay, because whenever you see this question, you can tell, okay, when and where. I can tell my distance from the top of the tower as well. I can tell my distance from the bottom of the tower as well. But because he specifically mentioned from the bottom the position as x, most probably he meant to ask what is the value of x in the ground. That is what is the value of the distance from the ground. Okay. Now a stone is allowed to fall vertically from the top of a tower. So there is a tower, there is a stone allowed to the tower of the height of the tower is what, 330 meter, and this is your 330 meter. And at the same time another stone, there is another stone at the same time, say at t equals to 0, both of them are at this position. Okay, at t equals to 0, both of them are at position, and it is projected vertically upwards with a initial velocity of 100 meter per second. Find when and where they will meet. Okay, this is traveling and this is also traveling, this is also traveling. Somewhere they met at t equals to 5. Okay, so that means both of them have taken same time at t equal to tc, same time t to meet. Okay, in here the initial velocity is 0. What I want is the height from where this point will meet. Okay, this is the height, this is the x given. I want x. Fine. So now let me write the equations concerned. So I'm going very systematic in my equation. So I know u, I'm writing for this particular motion. U, I have t because t is common for both the interval, both the motion. So I'm trying to include t so that in a hope that that will help me in getting me answer. So u, t, okay, he's talking in terms of heights, distances. So let me include s as well. I already know a for a projected motion, it's always g. So I'll think, okay, s, I'll go for this formula, s equals to ut plus half a t square. So now let me consider s as s1, and immediately I'll take sign convention as positive s1. U is 0, half a is plus g t square. So s1 I got as half g t square. Similarly, for this motion, again u is known here, that is vertically upwards 100 meter per second. You have t, because two motions you have something common, try to include that in your equations. And you have s and you have a. So my go-to equation is s equals to ut plus half a t square. So here s will be, if my sign convention upwards is positive, so s will be plus s2 equals to ut is upwards, so plus 100, time is t is common for both, minus half gt square. So because acceleration is minus c in the opposite direction. So now immediately I got an idea that mm, I thought because the total height is given, the total height is given as 300. Sorry, it's given as 300. So that height is equals to s1 plus s2. So I got an idea, let me add both of them. So I understand 300 equals to s1 is half g t square plus s2 is 100t minus half g t square. So if I cancel these two, we get t equals to 3 seconds. Finally you get t equal to 3 seconds, and you want x, it's nothing but s2 in t equal to 3 seconds. So substitute 3 equal to 3 seconds in this equation. So you get 100 into 3 minus half g, you can assume 10, t square is 9. So 300 minus 45, that is 255 meter. So this happens to be your distance of the particle from the ground, and the answer is 2. Why he got 255.9? Because he had assumed g as 9.8, but still even if you assume, you will not get that big difference. So you can always go with 10 and use the approximation accordingly.